Imagine a small town, a place with kids who love to splash in the local creek on hot summer days. For years, the creek was their playground. But one day, people started noticing something strange. The water, once clear, began to take on a rusty orange tint. The fish started disappearing. The plants along the banks turned brown and wilted. The creek was losing life, slowly. Upstream, a factory had been operating for decades, and a slow trickle of wastewater seeped into the ground, reaching the creek. This wasn't ordinary dirty water. It carried tiny, invisible particles: lead, mercury, cadmium. These are called heavy metals. They settle into mud, are absorbed by small organisms, and build up in fish, a process called bioaccumulation. You can't see, taste, or smell them, yet they're dangerous to ecosystems and people. Cleaning industrial wastewater is essential. We must stop pollution at its source. So, how do we get these nasty heavy metals out of the water? We have some really clever scientific methods. One of the most common and oldest tricks is called chemical precipitation. Add a reagent, form solid particles called precipitates, and let them sink. Think of milk curdling when lemon juice is added. Simple chemistry at work. We add special chemicals that react with dissolved metals. Invisible ions convert into visible particles, precipitates. Being heavier than water, they slowly sink. Sedimentation. We separate clearer water from metal-rich sludge. It's relatively cheap and removes many metals at once, a true workhorse. Downsides: lots of hazardous sludge to manage and potential traces left behind. Another technique is ion exchange. Imagine a sticky wall that only catches the red targets. Tiny resin beads are designed to grab heavy metal ions. Contaminated water passes through. Metals stick to the resin. The resin swaps a harmless ion for a toxic metal ion. It's incredibly effective even at very low concentrations. Cleaner water flows out the other side. When full, we regenerate the resin, wash off captured metals, and reuse it. Downsides: resin can be expensive and needs pre-filtration if water is dirty. Let's bring in one more player: membrane filtration. It's like using a superfine coffee filter. A thin barrier with microscopic pores separates water from contaminants. Water is pushed through under pressure. Metals are left behind. Reverse osmosis is a powerful type of membrane filtration. It removes a broad range of contaminants and produces very high-quality water. Challenges include energy cost and fouling. Membranes can clog and require cleaning or replacement. How do we choose? It's like picking the right tool from a toolbox. Chemical precipitation is a big, strong wrench. Powerful, reliable, cost-effective for large volumes and high metal levels. But it makes a lot of sludge and may leave traces. Ion exchange is like fine-tipped tweezers, precise down to extremely low levels. It often needs pre-filtration, and the resin adds cost. Membrane filtration is an all-in-one cleaning machine for all-around purity, with higher energy needs and maintenance for fouling control. There's no single best method. Many plants combine steps: precipitation for bulk removal, filtration, then ion exchange for polishing. The right sequence delivers safe, compliant, and clean water. When you look at a glass of clean, clear water, it's easy to take it for granted. Behind it is incredible science and engineering working to keep it safe. The creek that ran orange reminds us what happens when we're not careful, and that we can fix it. Chemical precipitation, ion exchange, membrane filtration, our frontline defense. These tools keep getting better, smarter and more efficient. New materials for adsorption, tougher membranes, greener processes, even recovering valuable metals. Imagine pulling copper or zinc from wastewater to make new products. Every properly treated gallon means fewer toxins in rivers, lakes, and oceans, healthier fish and wildlife, and safer water for our communities. The future of our water doesn't have to be orange and toxic. Thanks to science, we can keep it clear, clean, and full of life. And that is something to be very hopeful about.